Hey folks, we're back. Thanks for tuning in. DCD Studio here at DCD New York. I'm Sebastian Moss, editor-in-chief at DCD. Lots of DCDs being said there. We've got someone that's not DCD. Jake Ring, CEO, Digital Power Management. Welcome. Thanks for joining us.
Oh, thanks very much. I appreciate it. And enjoying the conference. It's been a good one so far.
So tell us a bit about what you guys do.
So Power and Data Management provides transformers. We are a actual builder and provider of the transformers that are dry type, medium voltage pad mount, oil filled transformers, and even high voltage transformers. But we have exceptional lead times.
This is the thing, right? When I think transformers, I think, I'm waiting. I'm not getting them. How are you getting those lead times down?
Part of it is our capacity. So we're able to actually bring the parts over from Asia to our factory in Salt Lake City, where we do the final assembly and test. That allows us to be able to produce the product very quickly, so that 9-week lead times are what we're able to do. Additionally, though, our factory has a 49% ownership through Eaton, which provides access to all of the components that Eaton manufactures. Their Cooper products, for example, the fusing, the switches,
right.
Those are right off the shelf. So you're not having to wait for the component. We're able to actually ship all of that in bulk.
Is that based on like a limited supply, or do you have just a open contract where you can get as much as you want?
We actually have the capacity to support 1,700 transformers a month.
Wow.
We can do 150 dry type transformers a week, so that PDU manufacturers that need that dry type transformer, they can get 30, 50 a week, and we can support them, with that same lead time.
So explain dry type transformers.
So a dry type transformer is not something in oil, but rather it's either been impregnated with the epoxy in a vacuum, or it's actually encased in a hard shell epoxy that allows it to operate in a corrosion environment, like in mining or chemical. But a VPI, or the vacuum impregnated type of product, is something that's used a lot in the data center market,
right,
to step that power from 480 to 415 so you can get it to the rack. And everybody's looking for those products. They used to be 225 kilowatts, 300 kilowatts. Now you're seeing 1,000 kilowatts, 2,500 kVA. So it's quite a big jump in the power demand, and that's why you need the bigger transformer. Presumably
that trend is not going to change. It's going to keep going up. Are there some kind of fundamental limits you see?
We see that there's going to be at some point a certain limit, because like I was talking with Bill Mazzetti, who's the head of data center design at Rosendin Electric. Really great guy, but he's also somebody that went to the different hyperscalers and said, look, you could build a rack that could do 300 kilowatts in the rack, but to hang the busway, it is so heavy, so large, so bulky, so difficult to do. Why would you?
Yeah.
More easy to standardize on something that is going to be more consistent, say 125 kilowatts a rack. And now you're able to have just more racks at that more standardized approach. And I see that that's where things are going to start to crest. But for example, on the AI side,
right,
the big thing that you see happening now is the buildup for training. It needs lots of power, because training models operate at like 95% of the total max.
Yeah.
When you go to an inference node, though, it's only going to be around 50-55%.
Only. It's still...
I know.
Yeah.
Instead of 125 kilowatts a rack, you're going to be at 60 kilowatts a rack. But you can do those.
But so the question is, if training then moves to the 600 kilowatts that NVIDIA's talking about, does inference move to the 125, or do you think it stays where it is and then just training goes off on its own?
Well, we'll probably, if you were to standardize, you see that kind of a standardization around call it smaller, 125, 160 kilowatts a rack. To have the inference node operating at around 50% of that, you're still going to need a lot of, anywhere from 8 to 10 times the number of data centers that are inference nodes versus training nodes. And so you'll see still a lot of power consumption, but now they'll just be spread over an even increasing number of inference nodes. And so I see the transformers are going to be serving from the grid at a larger pace. You'll need larger sized transformers at the substation to be able to distribute to multiple points on the distribution grid that's below.
And on that side, there are just crazy long lead times, right? On the giant,
And there, getting a transformer that long is that large is multiple years, 5 years from some competitors. But we're able to deliver those in 1 year.
Right.
And that's one of the other differences that we're bringing to the market. We have the capacity to do something faster because people need that product now.
Brilliant. Well, I look forward to having you back here in 1 year so we can see how many of those were delivered, what lead times are like then. Thank you so much for the time.
Well, thank you. I
really
appreciate it.
appreciate
It's
it.
really been a lot of fun.
And thanks for watching,
look forward
guys.
to it. Cheers.